right, so let's just briefly talk about a lot of these optimization problems involve some geometry. So what are some of our common geometric formulas? Probably ones you've seen at some point. And we've saw a few of them, or at least one of these, in the lesson today. Rectangle. There's 2 dimensions for a rectangle. And a lot of times we're interested in the area, which is x times y, or the perimeter, or some kind of related calculation more specific to the problem. So for a rectangle, you just add up the lengths of all the sides for a perimeter, so 2x plus 2y. We might have a 3-dimensional rectangle. I like to call those boxes. So maybe something like this. Sure. And because it's 3 dimensions, there's 3 possible dimensions. So there's x, y, and z. So what are some common, if we have a 3-dimensional box like this, what are some of the common type calculations you do? You might be interested in the volume. So that's x times y times z. You might be interested in the surface area. So that's where, well, you can kind of see for a 2-dimensional object, area kind of covers calculates how much space is inside the rectangle. And that's what volume is doing for a higher dimensions. So it's just calculating the amount of space in here. Perimeter, what is perimeter doing? Well, it's kind of giving you a measure of the sides. So you're just adding up the lengths of all 4 sides. Now for a 3-dimensional object, there's a similar type calculation, but this is where you add up the area of all 6 sides. So for a rectangle, you're adding up the lengths of all 4 sides. For a box, you're adding up the surface area. So you're adding up the area for each of those sides. So this might be x times y plus x times y plus y times z plus y times z. So for looking at this, x times y is like the base here, area of the base. X times y is also the area of the top. Y times z is the area for this right side. So, right. And it's also the area for the left side over here. And then the front face here, well, that is x, and then the height is z. So the area for this front face would be x times z. And for the back, also x times z. So what we're doing here for surface area is we're just going through, there's 6 sides to this box. We're just adding up the area for all of those sides. And you could probably simplify this down. So what do you get? You get 2xy plus 2yz plus 2xz. So this is kind of the 3-dimensional analog for perimeter. What else do we sometimes work with? Well, we also work with circles. So, there's a circle, there's a radius. What are some common calculations with circles? Well, there's area, so pi r squared. There's the circumference, 2 pi r. Might deal with cans, so cylinders, that's another thing we sometimes deal with. So cylinder can have 2 dimensions. There's the radius of the cylinder and then the height. So what's the volume? Well, the volume is just measuring the amount of space inside the cylinder, and this is pi r squared times h. And then the surface area, another gadget we might be interested in, is, what is it? It's 2 pi r times h plus pi r squared and pi r squared. So pi r squared, the first one is maybe the area of the top. The second pi r squared is the area of the bottom side here, bottom of our can. And then this 2 pi r times h, that's the kind of the area of the sides of our can, the label. So think of it like a soup can. And 2 pi r is the label, the area of the label. And then this is the area of the top and the base here. All right, so these are just some of the common geometric formulas, but there's others out there, so spheres and things like that. So you just want to be aware that these are pretty common geometric shapes. So there's some pretty, common geometric formulas that go along with them. Generally some kind of variation of area perimeter or volume surface area. So, feel free to kind of review over your your shapes, rectangles and squares and boxes and circles. There's some helpful geometric formulas out there. That might help with some of the optimization problems, because it comes down to, drawing a diagram and then picking out which shape you need to use. All right, so we're going to stop there for the optimization. Lots of good fun. And next time, what's our next lesson going to be? Well, I think we're going to start getting into the opposite of differentiation. I think that's coming up. So we'll see you there. Bye-bye.